So it's the review day for the big test, and I know it's also a Monday, but it's way better than just flopping a test on your desk and saying, good luck, right? We get to review first. Here we go. I hope, I gave you a little time before the video started here. I hope that you knew that this one is at x plus 3, because remember, this is what makes this as equal 0. So now I go squared because there was a bounce there. You know, this behavior here of going boing, that means this is squared. And then it's also going through 0. And so now if you put x plus or minus 0, I'm totally fine with that. And I will still not considered absent, so I'm glad you're here. This x plus 0, that's telling me that it has gone through 0, and since it's not bouncing, I don't put squared. Now, do you get that x plus 0 is the exact same thing as if I just said x? Like, it doesn't even have to be in a parenthesis. It could just be an x. And if it was just an x, you might as well put it in the front, because then it looks more like it's been factored. All right, welcome. You are late, but I'm happy you're here. All right, so there is your answer. And did you even think about whether the right end was going up? Because if you thought about it, you win. If the right end had been going down, it's hard to remember to notice that, oh, it's going down on the right. I need a negative. There should not be a negative here because it's going up. But if it had been going down, you'd need a negative. All right, so let's go through a few other practice problems. So y equals negative 3x, x plus 4 squared. You should be able to tell me not an exact graph of this thing, but a sketch. I don't even care where it hits. Just like, is it up or down on the right, and is it up or down on the left? And then you should be able to do the limits for it. So George, that negative in front, what does that tell us again? Down on the right. And then Nunez, on the left side, is it going to be the same or different? Different. Yes, because there's an x to the 1 here, and there's the x squared here makes negative 3x to the third is the lead term. If you didn't write that, it would have been smart. Now that you know they're going like this, and maybe it's something like that. We actually know because it's factored, but let's not worry about that too much right now. Because all I care about is the limits. If all I care about is the limits, I don't care what the x-intercepts did. All right, so this end, lim. Pontius, limit of the function as x approaches, for this one, what's x approaching? Yep. Because it's going this way. The y is also approaching something, what? Negative infinity, because it's going down. Now notice, I didn't care exactly what the graph looked like, I just cared about the ends. So, I think that's just make sure that this left end is written properly. Lim of the function as x approaches, well, x is this, and it's going that way, so it's going towards negative infinity. And then the y value, since this is about x, the other part's about y, the y value is going to infinity. Okay. If you look at these, is one of them always positive infinity and one always negative infinity? No. Just happened to be that way this time. All right. Next kind. Let's do one more graphing one, and I'm going to make it a little more difficult. Graph. Now you might be thinking, well, like, it's not factored, so therefore I don't have to like worry about the x-intercepts. No, you have to factor it. And therefore you have to have accurate x-intercepts. And is there a bounce or not? Is it going up or down on the right? So this is the part where factoring just has to be second nature. And I know for most of you, you're good. For those that are still not good at factoring, this test is going to kick your butt. And by now, if you haven't figured out that you factor out a negative 4x, I got to help with that, because if you didn't factor that out, you're going to get the whole problem wrong. So factor it out that way. I'll pause for a second while you make a graph that tells me the x-intercepts, tells me the y-intercept. Ooh, wait a minute, what's that? The y-intercept's where x is 0. You gotta know if it bounces anywhere. You gotta know if it's up or down on the left and right. So knowing the lead term would be smart. Lead coefficient. There's a lot to this. You got it factored?
2x.
2x, and then keep going?
Oh, wait, no, it's...
Oh, good. I'm glad you realized that it wasn't 2x. X plus 4. Now, how can you know you're right? You go this times this, and that makes negative 4x squared. Good. And then you go this times this, and that makes 16, negative 16x. And that's exactly what we wanted. So always check yourself after you factored. Okay, now we're going to graph this thing. That tells me an easy root. That root's at negative 4. Is there any bouncing going on? Nope, there's no squareds. Next, what's this one? I have people say that it's negative 4. I have people say that it's 0. And I have people that think that there is no x-intercept for that. Tully, what do you say? What do you,
0?
It is 0. Very good. Because what makes this part 0? That's really what you're asking. What makes this part 0? Negative 4. What makes this part 0? 0. So there's your two spots. Now, it'd be really easy to go like this and say, well, okay, I don't even know whether to start on the up or down on this thing. So I don't know, I'll just go like this. There. This kid got lucky who did it that way, because if they just kind of like start on the bottom left, you have a 50-50 chance. So what I would do is not how I did it. I instead would start on the right, and I see this negative, so I go, okay, it has to be going down on the right. And then I'd go backwards and go, is it bouncing there? No. Is it bouncing at the next one? No. So, okay, that's how I think it through. I don't just start on the left and draw. I always start on the right, because I know if it's up or down on the right. Okay, that one wasn't that bad, was it? Raise your hand if you're feeling like you could do that on a test. All right, good. Now, how about something more complicated? Can you factor that? Because if you can, then you know how to graph it. Let's just take a second. Practice hardcore factoring, and this was called factor by grouping. You group the first two terms together and you say, is there anything I can factor out of that? And there is. And then you look at the second two terms and you go, I wonder what I could factor out of that. X squared comes out of the first one. Okay, dice of destiny, choose wisely. Row one, last person. Ryan Bontius, what do you say? X squared came out, and what do you have after that? X minus 3, good. And Ryan, what comes out of this part then?
2.
I'm going to put a positive 2 because it wasn't a negative 2, right? And then X minus 3 again. And if these don't match, you know you probably did something wrong because they need to match. All right, Clara, can you tell me what the final answer is then?
Is it x squared plus 2, and then in another parentheses, x minus 3 squared?
So close, just don't square it.
Oh,
The reason you don't square it, I get it, you're thinking there's 2x minus 3's, right? Is when you factored out this 2, for example, you didn't square the 2, you just put it in front. Right? I mean, there was a 2 in this and there was a 2 in that, and so you just put it in front. You didn't square it. So it's the same concept. This and this, there's 1 in each of them, so you just put it in front, but don't square it. All right, cool. That's pretty difficult factoring. Now, different kind of question completely. What's the lead term? Be careful. You don't have to actually multiply this all out. You have to just kind of act like you did and just tell me the lead term. And that should tell you the lead coefficient, which is part of the lead term. And then you should be able to tell me the right end and the left end. I'm not going to ask you to tell me the x-intercept because it's just too big of a number. It would be a really big number. All right, act like this is a test question, but on this test, you get to check with the kid next to you and before you turn it in, see if you got it right. Now, if you have a different lead term, which is very likely, because a lot of kids miss a negative or screw something up, would you please talk about your first term? If you have a different first term, lead term, talk about it with them so you can learn something. All right, I'm going to pause while you finish this, talk about those 4 answers with the kid next to you. We're back. Most of the kids talked to the kid next to him already. And the lead term was this squared and that and that. Those are all the lead things. So I put them all together and I get x squared and another x makes x to the 4th. That's the easy part, is just how many x's should I have. And then I got a 4 and a negative 2, and that's just a 1 in the front. So the numbers, that gives me negative 8. Raise your hand if you had negative 8, x to the 4th. Sweet. Then the lead coefficient is the negative 8. What's its specialty? Its specialty is telling you that the end's going down on the right end. Then the left end, well, since this is a to the power of 4, they should be the same. So down on both of them. You get that this tells you the other end has to be the same. If it had been odd, it's saying the other end is different. Okay. Now that you know this, would you please tell me the left limit? You can draw the picture if you want. You don't have to. You're getting good enough at this. I think you could be able to tell me the left limit without having to draw it. Okay, so I do like to make the sketch because it's going down on this end and down on that end. And I don't even care that much about where the x-intercepts are, because if I'm just writing the limit, then I just need to know that it's kind of going that way and that way. All right, so the left end limit is that one, and I write lim of the function as x approaches negative infinity. Why negative infinity? Because it's going this way. And it's also going that way. So when it comes to the y is approaching, see, this is the y direction, it's going towards negative infinity. So negative infinity, negative infinity. Okay, cool. I feel like you're getting this. So I'm going to give you the hardest problem of them all. So tell me, on this one, I would like you to sketch, well, first of all, let's figure out the lead term. Let's figure out the x-intercepts. Lead coefficient comes from the lead term. The right end, the left end, the y-intercept, and then a graph. This represents pretty much everything all in one problem, except really hard graphing, or really hard factoring. I guess we'll end with that. Okay, now act like this is the summary of the whole thing, because it is, pretty much. So, carefully go over each part. Just go one at a time, like what'd you get for the lead term? What'd you get for the x-intercepts? And talk to that kid next to you and see if you've got the same answers for all of this. So here's how it came out, the lead term. Did you notice the negative? Because it changes everything. That squared means 4 x's, so x to the fourth, but then there's a negative 2 and no other lead number, so it's just negative 2 x to the fourth. The lead coefficient is the negative 2 of that. The x-intercepts are what make y equal to 0, so what makes the whole equation 0? 0. And 7, those are the easy ones. X equals 0, I would have accepted, or since it's an x-intercept, you could have made y 0, 0, comma 0. This is the other easy one, and it's 7, so you should have had x equals 7, or 7, comma, x-intercepts are where y is 0. And the third one is this, so I go off to the side and say negative 2x plus 1 needs to equal 0. Would you have known that? How many of you did that? Raise your hand if you saw that. Okay, good. Then I have negative 2x equals negative 1, and then x equals, and the negatives cancel. Were you careful enough? Positive 1/2. And if you're not sure, you go stick it in. Stick in a half right here. And then it turns into negative 1 plus 1, which is 0, which is what we wanted. Positive 1/2. And then that's 1/2 comma 0 if you wanted to write it that way. All right, the right end, since this is negative, the right end is going down. Since this is even, they're both the same. And then the y-intercept of it is where x equals 0. Look, if I put 0 here and here and here, it really doesn't matter much because 0 going here makes the whole thing 0. So the y-intercept is 0, 0. All right, and you could have known that if you'd have just graphed it. So here's the graph of it. Goes through 0, 0, boom, the y-intercept is 0. It goes through 7, 0, which is right here, let's say. And it goes through 1/2 comma 0, which is like, I don't know, somewhere near 0. And it's going down on the right, remember that? because of this negative in the front. So I always start on the right and I go, okay, and is it bouncing there? Is it bouncing there? Is there any place it bounced? It bounced here. Did you notice that? It bounced at the 7 and then just passed through and passed through. Is it down in the right places? Yep, they're both down. Does it have a bounce? Yep, it does, right there. All right, if you did all of that perfectly, you're on track for an A tomorrow. Okay, but here's your last assignment. It's 4 problems. It's like the hard part of the test, and it's on paper. So try this. Totally think it'd be smart to check with the kid next to you. Answer key will go up later today. You know, our tests aren't just 4 questions, but I made these 4 questions try to cover pretty much everything. It doesn't cover everything. So between the review problems we've done together and this, pretty much covered everything. All right, and that is all we have for the review for today.